and welcome to another video. In this video we are going to solve lowest common ancestor of a binary search tree problem from the Leetcode. In this problem they will pass a pointer to the root node of a binary search tree, and they will also pass pointer to two nodes, that is P and Q. We need to find out what is the lowest common ancestor for those nodes. Consider this first example where the given tree is described in this image and given nodes are 2 and 8. So for 2 and 8 the common parent is 6. So 6 is the output because 6 is the lowest common ancestor for 2 and 8. And consider this second example where the given nodes are 2 and 4. If you observe here 2 and 4 is a child node of 2. So 2 becomes the lowest common ancestor. This is something that we have to keep in mind while writing the solution. There are also other conditions in this problem statement. They have also mentioned that all the node values are unique and P and Q are not equal, and P and Q will exist in binary search tree. So based on these conditions we can simplify our solution to write a simple algorithm. So in order to find the lowest common ancestor, the simple thing that we can do is, what is the condition for 2 and 8? If you want to find the lowest common ancestor, if you are at a root node and if P is present to the left and Q is present to the right, then root node will become, in the right means right subtree. That means root node will become the lowest common ancestor. So if P is present in the left subtree and Q is present in the right subtree, then root node will become the lowest common ancestor. In a similar way, if Q is present in the left subtree and P is present in the right subtree, then also root node will become the lowest common ancestor. So at any point, if we get to know that if our root node becomes equal to P or Q, then that node itself will become the lowest common ancestor. Because consider this second example, here root node itself will when we go through this left subtree, root node itself will become equal to 2. So this itself will become the lowest common ancestor. So keeping these things in mind, and if we know the properties of binary search tree, from the root node every value to the left subtree will be lesser than the root node, and to the right subtree we will have values which will be greater than the root node. Considering all these properties, let us write solution for this problem. And let's say we can declare a pointer which will point to the root node. Let's call it as current, and we are going to initialize it to root node. And then we start this while loop, while current. What we are going to check is, first we need to check whether we are looking at a proper root. So that we can check if our current value, that is value present at current, is greater than value present at P, and if it is also greater than current dot value, if it is also greater than Q dot value, then this means, so our current node, whatever the root node that we are considering, it is both greater than P and Q. So it is possible that then there is no point in searching to the left side of the tree. So since the current value is greater, so every value to the left subtree will be lesser. So we need to go towards the left. And another condition is, let's say we are at a current root node, and if it is less than the P value and it is also less than the value present at Q, and in this case we should move to the right of the current node, right subtree, because all the values which are present to the right will be greater than the current dot val. So there is a better possibility that we can find a lowest common ancestor in the right subtree. So if this is not the case, then what is possible? In this else case, it is possible that our current value lies between P and Q values. So that is one possibility. In that case, we know that current node itself will become the lowest common ancestor. So what are the other possibilities? Current value can become equal to P value, or current value can become equal to Q value. In that case also, we know that our current node itself will become the lowest common ancestor. And finally, we can anyway that if we don't get anything, we can return the current. So let us submit this solution and check whether it passes the initial test cases. Yes, as you can see here, this solution is passing the initial test cases. Let us submit this solution and check whether it passes all the test cases or not. Yes, as you can see here, this solution is passing all the test cases. This solution is simplified because of the problem statements which are given in the explanation. Since it is a binary search tree, at each current position we can take decisions based on the value of the current node. If it is greater than the P and Q, then we know that there is no point in searching to the right side of the tree. We will move the current to the left subtree. If it is lesser than both the values, then we will move to the right subtree. Otherwise, if the value lies in between P and Q, or if it is equal to either P or Q, in that case current itself will become the lowest common ancestor. I hope you like this video. If you are interested in learning more about other data structure and algorithm related problems, consider subscribing to this channel. Thanks for watching this video.